All right. All right, ladies and gentlemen. Okay, one last thing to talk about electrons. Children, the adults is talking. Okay, so we talked about electron configurations, 1s2, 2s2, 2p6, and we talked about noble gas shorthand, argon, 4s2, 3d, whatever.
Teachers at this time, please release freshmen with the last names A to K to the lecture hall. 9th grade, last names A to K to the lecture hall. Thank you.
All right, anyway, so now we're going to talk about ions. Now we remember that an ion is an atom that has gained or lost what? Electrons. So an ion is an atom that has gained or lost electrons. Now if you look at chlorine, you find chlorine on the periodic table, chlorine ends, its last orbital is what? Level what? 3p5. So it's level 3, it's in the third period, level 3, p block 5 over, chlorine's last orbital is going to be 3p5. Now if chlorine gains, okay, so first of all, give me a thumbs up if that makes sense to you. Okay, cool. Now chlorine gains an electron. If it gains one, it's going to form a negative ion or a positive ion? Negative ion. So if chlorine forms a -1 ion, it's going to look like what?
Argon.
It's going to look like argon. So if chlorine gains one more electron, it's going to look like argon, and the 3p5 will become 3p6. Okay, does that make sense? So when atoms become ions, they gain electrons, becoming negative, or they lose electrons, becoming positive, and that gain and loss affects their electron configuration. Chlorine's 3p5 becomes 3p6. Sulfur would normally have a 3p4. If sulfur gains 2 electrons, it's also going to look like argon, and it's going to look like 3p6. Does that make sense?
Yeah.
Okay. So that's what we're talking about today. We're talking about atoms gaining and losing electrons and how we write their electron configuration. So this is the noble gas configuration for sulfur. Sulfur is neon, 3s2, 3p4. So there's neon, first 2 rows, 3s2, 3p4. If sulfur gained 2 electrons, write down on your paper what sulfur's electron configuration would look like if it gained 2 electrons. If that boiled and splattered, you better get in there with a paper towel. Did it splatter?
No.
Okay.
Oh, no,
It's everywhere. There's nothing left in the bowl. It's all over the place. Okay, so hopefully you realize that neon 3s2, 3p4, if it gained 2 electrons, sulfur 2- is going to be neon 3s2, 3p6. Now again, when we're writing ions, we can write them 2- or -2. Nobody cares. Some people will write sulfur -2. Some people will write sulfur 2-. No one cares. So as long as you realize it's a negative. In fact, some people write like negative, which is that's a problem for me. So sulfur 2-, sulfur -2. It has gained 2 electrons. Each electron is -1. So our 3p4 became 3p6. Okay. We are still madly scribbling. Give me a thumbs up if that idea makes sense to you. Okay. But give me a thumbs down if you have a question. No? No questions? All right. Now it works the other way too. If you find, let's look at magnesium. There's magnesium. Magnesium's hanging out right here. If you look at magnesium, you realize that magnesium's last orbital is what? 3s2, exactly. So magnesium is 3s2, level 3, s block 2 over. So magnesium is 3s2. If magnesium is going to lose an electron, it's going to look like sodium. If it's going to lose 2 electrons, it's going to look like what? Neon again. Okay? And that's what it does. So look at calcium. This is calcium's entire electron configuration. If calcium's going to lose electrons, it has a goal. All atoms have a goal. They all, write this down, all atoms want to look like noble gases. All atoms want to look like noble gases. If you're an atom, that's your goal. You're going to steal, give away, share. You're going to do something with your electrons so you can look like noble gases. And that's the basis for the next 2 units. What atoms do with their electrons so they look like noble gases and they attain what's called noble gas stability. That's the ultimate goal. If you're an atom with 3p6, you're happy. If you're an atom with 3p5, you want to be an atom with 3p6. Does that make sense? Now calcium here has a 3p6, but it's also got a 4s2. So if it's going to lose electrons, what electrons will it lose? Yeah, the 4s2. So calcium is going to form a +2 electron, or +2 ion, by losing its 4s2 electrons. Okay. It loses 1, becomes a +1 ion. It loses 2, becomes a +2 ion. And the 2 electrons it's going to lose is the 4s2. Because now we have something kind of interesting. Both sulfur 2- and calcium 2+, they both look like what? Close. Argon. Yeah, they both look like argon. So they're both happy. Sulfur by itself, not happy. Sulfur 2-, that's a happy atom, or ion. Calcium by itself, not happy. Calcium 2+, that's a happy ion. They both look like noble gases. Okay. Does this weird idea make sense to you? Okay, question.
So if you're adding electrons, it's always a minus, and if you're subtracting, it's always plus.
Yes, yeah. Since electrons are negative, when you add them, you become a negative ion. When you lose them, you become a positive ion. Okay. Other questions? That was a good one. Yeah.
Is helium considered a noble gas?
It has noble gas properties, but let's not use it for the purposes of noble gas notation. In other words, don't write for oxygen helium 2s2 2p4. It's just don't bother. So yeah, helium is a noble gas. It has properties of noble gases, but it's simply don't bother with it for noble gas notation. Some people do. I think it's kind of sloppy. Yeah.
So if you had lithium, and it would want to become helium, right?
Exactly. Yeah. If that's what you were asking, yeah. If you had lithium, it would want to become helium. It would want to give up that last electron and look like helium. Okay. Excellent questions. Shall we move on? Let's move on. Okay. This is weird. I don't make the rules. It's just the way the rules work. We remember that the 4s electrons are lower in energy than the 3d. But if an atom has 3d and 4s electrons, the 4s electrons are further from the nucleus. Even though the 3d is lower in energy, the 4s is the 4th level way out here. If an atom is going to lose the 3d or the 4s, they lose the 4s. Guys, does that make sense? Okay. It's weird. It's not reverse filling order. Atoms gain electrons in filling order, but they do not lose electrons in filling order. Okay? They lose the higher level first. They will lose the 4s before the 3d. And they'll lose the 5s before the 4d. Does that make sense? Cameron.
So it's dependent on the number 5, whichever covers.
Yeah, whichever level. Yeah. Whichever primary level is the highest, those are going to be the electrons the atom's going to lose. Okay. Shall we move on to something new? C. Question?
Can you give another example of that?
Sure. Okay, so the one we're going to do in our notes or our practice is titanium. So titanium's hanging out right here. It turns out the most stable ions for almost all 3D atoms is +2. Because if you're going to lose electrons from either 3d or 4s, the 4s electrons will be lost first. So if you have titanium and you say, hey titanium, what's your favorite ion? Titanium's going to be like, my favorite ion is +2. How do you lose those 2 electrons, titanium? I lose the 4s2 because they are higher in energy than the 3d2. So that's how titanium loses. Similarly, iron, hey iron, how do you lose your electrons? I lose the 4s2 because the 4s2 are further than the nucleus than the 3d6. Make sense? Moving on. Okay. Actually, I want to come back to this. That shape that stop signs are, that has 8 sides, what do you call that? Octagon? And that sea creature that has 8 tentacles, what do you call that? An octopus? Okay, so in atoms, atoms' ultimate goal is to have what's called an octet. An octet is 8 electrons in its highest level. An octet is 8 electrons in the highest level. And that's, if you're an atom, that is your goal. You will give, take, and share electrons till you complete your octet. And it's always in the highest level. Now sulfur has how many electrons in its highest level? 6. Not happy. Sulfur 2- has how many electrons in its highest level? 8. That's happy. Calcium has how many electrons in its highest level? 2. Yeah. Calcium's highest level is 4. Calcium has 2 electrons in its highest level. Not happy. Calcium 2+ has how many electrons in its highest level? 8. Happy. 3s2 and 3p6. So that's called an octet. Does this idea make sense?
Yeah.
1 then 2.
So if, okay, I don't know how many next, but would 4s, so if we had like 2 and 4s and 6 and 10 and d3, then that would be 8. It's like in these
No.
rows?
No, because the 3D is in the 3rd level, the 4 is in the 4th level. In fact, we almost never count the D's for octets. Almost never. In this class, never. In AP Chem, if I remember my curriculum.
Is every noble gas an octet?
Yes, which is why noble gases generally don't want to react. They've already got their octet. They're perfectly happy. So, another question?
So are those the only ones with octet?
Naturally, yes. Yeah, the noble gases are the only atoms that naturally have an octet without any kind of bonding, without any kind of moving electrons around. And that's the next 2 units, is what happens when the electrons get moved around. Okay, so, question?
I just don't get how to find the highest level.
The highest number, the highest big number in front. So 1s2, 1. 2s2, 2p6 is 2. It's the number in front. So 2p6, it's the number in front. So back to this slide. The highest level for calcium here is 4. The highest level for the calcium ion is 3. So this is level 1, level 2, level 3, level 4. Level 1, level 2, level 3, level 9. Does that make sense? It's the big numbers. Big number, big number, big number. Okay, let's play a little mental exercise. So when you guys were in elementary school, you collected Pokemon cards.
Oh, for sure.
Yeah.
Yeah.
It was all about that Yu-Gi-Oh!
It was all about the Yu-Gi-Oh!
In Korea, it was.
Okay, so you collected Pokemon cards, and let's say you were trying to collect a set of Pokemon cards, and let's say there's 110 of them. If you have 109 Pokemon cards, and all that you're left with is that rare Charizard, what are you going to do with your spare time?
Save that rare Charizard?
You're going to try to get that rare Charizard. If you're missing, that's the only card you're missing, you're going to try really hard to get that one. You're like, I got 109 cards, only one more and I'll have a full set, so I can say, see, I got a whole set. So you're going to work really hard to get that last electron, if you're an atom. atoms that have 7 electrons work very hard to get that last electron. So if you got 7, you're 1 away from an octet, you're going to work very hard to get that last electron. That is the basis for chemical bonding. On the other hand, let's say you had a birthday and now you got like 130 cards and the set is only 110. Do you care about those last 20? Not really. You're not going to throw them away like a bum. You're like, oh, I'm just going to throw these away like a jerk. But you're probably going to try to trade them away and try to do something to get something better because you don't care about those extra cards. Electrons do the same thing. If you, like calcium, if you got an octet and a couple extra, those extra ones you simply don't care that much about. Make sense?
Yes.
Okay. So that's the basis of how things bond. The valence electrons are the electrons in the highest level. The valence electrons are the electrons in the highest level. We'll talk about oxidation in the next unit. But just understand, the valence electrons are the electrons in the highest level. If you have 3p6, or 3s2, 3p6, it's the 3s2 and the 3p6. Those are the valence electrons. The valence electrons are the ones that do all the action. They do all the bonding. So, and an octet is 8 electrons in the highest energy level, or 8 valence electrons. When you have 8 valence electrons, you have an octet. Neon, 2s2, there's 2, 2p6, there's 6 more, for a total of 8. Argon, 3s2, there's 2, 3p6, there's 6 more, for a total of 8. Argon and neon have natural octets. They're pretty happy. They're like, we got octets, we don't have to do anything. We're like the rich kid. Your parents give us money, we're already done. Let me go forward in the back. Yeah, okay, cool. On the back of your crossword, you will find today's activity. It's the beastly thing with all the little boxes. So take